what is the power generated by a generator that produces 100 volts and 5 amps of current. So we have a voltage and we have a current. Yes. Yes, it's going to be fine. I think there's only 2 questions that aren't math. So, we come over here. We are solving for power, so it's going to be one of these 3 equations. If you are given current and voltage, this is your equation for power. Yes, so our equation literally tells you to solve for power given these variables. Power is current times voltage, or current is 5 amps, or voltage is 100 volts. And so we have 500. And if we're in base units, meaning amps, volts, seconds, and so on, power is in watts. What is the resistance of the generator that generates 5 amps of current and 100 volts of voltage? So we're given I, and we're given V. So we're given current and voltage. Again, we look at the formula sheet. We're trying to solve for current, and we're given voltage and current. We're solving for resistance, and we're given voltage and current. So resistance is voltage divided by current. The equation is resistance is equal to voltage over current. This is from Ohm's law. Voltage is equal to current times resistance. So voltage is 100 volts. Current is 5 amps. So this is a 20 ohm resistance. And resistance uses ohms. How much energy does a 100 volt 5 amp generator produce in 1 minute? Or I should say, produce every minute. So energy, again, looking at our equation, energy is power and time. So energy is equal to power times time. If we want energy in joules, so for energy to be in joules, power must be in watts, and time must be in seconds. So our power is 500 watts, or time is 1 minute, or 60 seconds. And so we get 3,000 joules. A joule is the same thing as a watt times a second. A joule equals a watt times a second. It's literally a watt times a second. So yes, you could replace joules with W, and we usually do not for units. Yes. If it asks you for kilowatt hours, then it's a kilowatt times an hour. Yes. Note also, if you wanted to convert this in using SI, 1,000 is the same thing as a kilo. So I could have put this as 3 kilojoules. Because a K stands for 1,000. So 3,000 is the same thing as 3K. That's why if you're playing video games and it pops up that you have made 10K, that means you made 10,000. A watt times a second. So it equals watt times second. What second? The voltage drop across a 20 ohm resistor is 40 volts. So our voltage is 40 volts. The resistance is 20 ohms. So we can solve for power. Was power by looking it up. Power, if given voltage and resistance, is equal to voltage squared over resistance. Power is equal to voltage squared over resistance. So the reason why it's called a drop here is because voltage is relative. This voltage drop could go from 180 volts on one side of a resistor to 140 volts on this side. No, this is just an example. The drop, or the voltage difference, or the electric potential, is 40 volts. It could be 1,080,000 to 1,040,000. As long as the difference between them, it makes no difference. Electricity only depends on the difference of voltages. So right here, the voltage is, for example, 180 volts, but it drops down to 140. Hence, we would call it a voltage drop of 40 volts, because the voltage drops as you go across the resistor. So the power is 40 volts squared over 20 ohms. So 40 squared is 1600 divided by 20, which is equal to 80 watts. What about the current? Again, we'll solve for current given voltage and resistance. We use this equation right here. Current is equal to voltage over resistance. Square root. That's a bit of. Yeah, I mean. So the voltage is 40 volts. The resistance is 20 ohms. And so we get current of 2 amps. How much thermal energy is produced after 5 minutes? We usually measure thermal energy in joules. So energy is equal to power times time. And we want our power in watts, our time in seconds. Power is 80 watts. And 5 minutes is the same thing as 300 seconds. And so we get 80 times 300. That's 24,000 watts times a second. Now, watt times a second is the same thing as 24,000 joules. If you want to go a step farther, you can write that as 24K joules or kilojoules. Five amps, and right up. 5 amps of current flows through a 10 ohm resistor. So our current is 5 amps. or resistance is 10 ohms. So again, we do the same thing. What is the power? So power, given current and resistance, power is equal to current squared times resistance. We're trying to solve for power, given current and resistance, we use this equation. Power would be 5 squared times 10. That's 25 times 10, which is equal to 250 watts. What about voltage? Voltage, given current and resistance, is 0. Voltage equals current and resistance. So current is 5 amps, resistance is 10 ohms, so the voltage is 50 volts. How much energy in kilowatt hours, same thing as kWh, is produced in 7,200 seconds? So energy is equal to power times time. We want our power in kilowatts, and our time in hours. So our power is 250 watts. To convert watts into kilowatts, do this. Divide by 1,000. 250 divided by 1,000. So we divide by 1,000. We get power equal to 0.25 kilowatts. Our time is 7,200 seconds. To convert seconds into hours, divide by 3,600. Divide by 3,600, and we get 2 hours. So to get energy in kilowatt hours, we multiply by 0.25 kilowatts times 2 hours, which gives us 0.5 kilowatt hours. If electricity cost $12 cents per kilowatt hour, how much does it cost to run electricity through this resistor? So we've already calculated the total number of kilowatts. So the total number of kilowatts is 0.5 kilowatt hours. We calculate total energy, and it is 12 cents per kilowatt. So we multiply 12 cents per kilowatt to our total number of kilowatts, and we get 6 cents. A 100 volts is applied to a light bulb that generates 50 watts of power. That consumes 50 watts of power. So our voltage is 100 volts. Our power is 50 watts. Let's solve for the current. So what is the current? Well, again, looking at the formula sheet, current is given power and voltage. Current equals power divided by voltage. So current equals power divided by voltage. Our power was 50 watts. Our voltage is 100 volts. That's equal to 0.5 amps. What about resistance? So resistance given power and voltage is equal to voltage squared over power. So resistance, and yes, there's other ways of doing this. Resistance is equal to voltage squared over power. So that would be 100 squared over 50. 100 squared would be 10,000. 50 is 200. So the resistance of the light bulb is 200 ohms. Yes. how much energy is used, and we'll use kilowatt hours, in 24 days. So to do kilowatt hours, we want our power in kilowatts. Our power was given as 50 watts, but we want it in kilowatts, so we need to divide by 1,000. And so that's equal to 0.05 kilowatts. And our time is given in days. So we know that there is 24 hours per day. So 24 hours per 1 day. So we multiply by this. Days cancel out, and this is hours. So that's equal to 576 hours. And so energy is equal to power times time. For power is 0.05 kilowatts. Our time is 576 hours. And that's equal to 28.8 kilowatt hours. How much would that cost? Assuming it's 10 cents per kilowatt hour. And this is our ratio. We take our total energy and multiply it with the ratio of 10 cents per kilowatt hour. And we get $2.88. Five amps of current is used to power a 100-watt light bulb. So our current is 5 amps. Our power used is 100 watts. So let's solve for everything else. So let's solve for voltage. Voltage is given power and current equal to power divided by current. Voltage is equal to power divided by current. Our power is 100 watts. Our current is 5 amps. So our voltage is 20 volts. What about resistance? Looking at the formula sheet, resistance is equal to power divided by current squared, where power is 100 watts, or current is 5 amps, but we square current. Yes, so we're almost finished. You want to wait a minute or two. So 100 divided by 25 is 4, so it's 4 ohms. How much energy is used in 5 years? And we want kilowatt hours. So power is 100 watts, but we want watts and kilowatts. So we divide by 1,000. So that's 0.1 kilowatts. So time is equal to 5 years. We need to get years and hours. So it's 365 days per 1 year. Years divided by a year cancels out. So we're in days. There are 24 hours in 1 day. Days cancel out, and now I'm in hours because that's the only unit left. So that's 5 times 365 times 24. Dividing by this 1 and dividing by this 1 doesn't do anything. I usually leave it off. I don't usually divide by 1. 43,800 hours. So this is kind of like asking what would how much would you, so let's say a light bulb lasts on average 5 years. It can run for 5 years continuously. How much over the course of its entire lifetime would it cost you in electricity? So first, let's figure out the total energy. Energy is equal to power times time. So that's 0.1 kilowatts. This is a 100-watt light bulb. Yeah. There are 100-watt light bulbs. I've used them before. They're really bright. But you probably wouldn't want to use a condensate one that actually uses 100 watts. You'd want to use a LED. That'll save you a ton of money. So this is 4,380 kilowatts hours. Kilowatts and hours. And how much would that cost at a rate of 12 cents per kilowatt hour? So we have our total 4,380 kilowatt hours. We multiply it by our rate of 12 cents per kilowatt hour. Kilowatt hour gets removed because you're dividing it itself, and so we want to get dollar signs. And that'll cost you, that one little $5 light bulb would cost you $525.60 over the course of its lifetime. Note, even though the calculator says 0.6, when dealing with money, we always write it to 2 decimal places. Let me look up and see what the other 2 questions were. So let's compare, for example, let's compare a 60-watt light bulb to a 75-watt light bulb. So, what's one thing that stays constant in the house? Your AC is whatever outlet does what? What is it producing? Voltage. So all the outlets are held at 120 volts. That's constant, doesn't change. So what must be changing in order for it to produce 60 watts? It must be the current that is changing. So 120 volts is constant for every device in your house. Every device in your house is at 120 volts, except for maybe your drying machine, which is at 240. Household electronics are all use the same voltage. What's different between them is the current they draw. You can change the current by increasing resistance or lowering resistance. So how much current is in this light bulb? So current, given power and voltage, current is equal to power over voltage. So that would be 60 watts over 120 volts. So that's 0.5 amps. And let's do the same thing for this one. So current equal to power over voltage. Power is 75 watts over 120 volts. So that's equal to 0.625 amps. So this light bulb uses more current. Let's look at how does it achieve this. You really can't control how much current goes through it. But what you can do is design resistance. So let's look at resistance. Resistance given power and voltage. Resistance is equal to voltage squared over power. So voltage is 120 squared over 60. That's 240 ohms. And for this one, so resistance is equal to voltage squared over power. So that's 120 squared over 75 is equal to 192 ohms. And that's really what these light bulbs, or at least the old ones, were. You basically take a very thin filament. So remember, the thinner the wire is, the more resistance it has. And so it has a very thin, it's very windy. Yes. So all it is, all the old light bulbs were, is a very thin wire. That's all it is, very thin wire. And they just make it so that the wire has a resistance of 240 ohms. They control the thickness and how much wire is here. And they just keep adding coils until we get to 240, and that produces a 60-watt light bulb. If you remove some of the coils, or make it thinner, usually you don't want to make it thinner, but if you remove some of the wire, you can reduce it down and get a brighter light, as it's going to be allowing more current to flow through it. And we get 192 ohms. And because there is less resistance, that means more current. So this has a bigger eye, not that much, but a bigger eye going through it. And so a 75 watt light bulb has more current but less resistance. So less resistance means more current can go through it. The property that resists the flow of current. So the 60 watt would use less amps. Another thing is about fuses. A fuse breaks when too much current goes through it. It technically melts. This is the actual shape. A breaker has so a difference between a fuse. A fuse, this metal will melt and break, and a breaker is so they have a latch right here. And so you have this metal right here, and it's barely catching on to right here. When this heats up, this wire will bend and be able to slip out. So what happens is, as this heats up, the metal will bend, and then it'll flip upward. So here in a fuse, the metal actually melts, and the fuse no longer can be used. So it actually melts and breaks the current. Here we have a thin piece of metal. As this heats up, it flexes, and because it's just barely catching on here, it will eventually bend upward and flip off. That's you tripping the circuit breaker. So this is a breaker versus a fuse. Fuses, whenever they break, you have to replace them. Breaker, all you have to do is push this clip down back under here, and current can then go through it. So this is metal, that's metal, so current can go through the two metals. As this bends, because as you heat up metal, it becomes softer and softer and more flexible. And there's a certain current at which a fuse will break or a breaker will trip. So, for example, suppose we had a 10 amp fuse. And we connect it to 100 volts and a 5 ohm resistor. What will happen? Well, we need to figure out the current. Current would be the voltage over the resistance. Yes. Yes, but usually your breaker will. Did you do what was your question? So 110 and 120 are about the same. Usually things that are expected 120 will still sometimes work with 110. And some things that are 110 will still work with 120 because they're very close. So this is more current than a 10 amp can supply. So the fuse will break. As long as your current is less than 10 amps, it's as if you don't have a fuse at all. Fuse acts like a straight wire. What's the equivalent of a watt? What units is a watt equal to? So let's look up the equation. So power is current times voltage. So amps times volts. Power is, so let's look at this equation. Energy is equal to power times time. So doing a triangle, energy is equal to power times time. So power is equal to energy over time. So a joule over a second. And that's it for the review. Bye.